In this chapter, we will focus on not only SQL, types of NoSQL systems. NoSQL systems is not only SQL, and what they do with respect to retrieving data. In addition to these concepts, you will see how certain NoSQL systems work in other videos provided to you on the Learning Management System. Distributed databases and storage systems are stored on different networks and pass messages back and forth. There are many fields using NoSQL, and you have experienced NoSQL at work without even knowing it. Google, Amazon, and Facebook utilize their own NoSQL systems based on their company needs. Here are some of the more common NoSQL systems and the way they work. XML is a data storage tool often used in web development. There are a number of areas NoSQL systems focus on. The idea is the more data you have, the more reliable your SQL system must be. Since NoSQL systems are big data heavy, some common SQL features you may take for granted are not as useful or used in NoSQL. These are ways you may use a NoSQL system. Depending on your needs, you may choose a different type of NoSQL system for each task you intend to complete. CAP stands for consistency, availability, and partition tolerance. Ideally, users are looking for the best experience possible. Since we can only guarantee 2 of 3, consistency is often the one which takes a back seat. NoSQL systems can retrieve data from many sources. XML is data storage, often used in web development, as is JSON, which is a JavaScript object notation. MongoDB is one of the most commonly used NoSQL systems today. Think of object ID as a label for the document. As we have seen previously, often insert and delete are the two most common commands associated with databases. Here we see how to run these commands in MongoDB. Here we see additional representation of MongoDB documents. Ideally, you want to make sure your data has no issues associated with it, so you may create copies of documents to avoid data loss or other issues. We can make a copy of a document and limit another user's capabilities when using it. No, we are not saying sharding here, but sharding. Think of shards of glass or small pieces. Here we dive deeper into how sharding works with MongoDB. Just like with SQL, we have requirements to meet. We now shift our focus to key value stores, which relate a key and value, or piece of data. DynamoDB is considered more user-friendly than other NoSQL systems, but that could simply be due to its association with Amazon. For you college scholars, you may want to use the equivalent open source Voldemort key value data store. Here, you see a visual representation of the partitioning previously discussed. There are many key value data stores not listed here, but here are some of the commonly used ones. Column-based NoSQL systems are commonly used when our data is large in nature or scope. HBase differs from what you have seen in SQL normally. Rather than just the current state, like most database tools, HBase will store multiple versions with timestamps. Here is a visual of code you would use within HBase. As you have seen in SQL, one of our most common tasks is updating the data table. Get and scan are additional commands to help us retrieve data. HBase visually looks different than anything experienced unless you've used it. The most commonly used graph database NoSQL system is Neo4j, which will be provided videos on how it is used. Here, you see how codes relate in Neo4j and how they are created. Here, you see Neo4j commands creating nodes and relationships. Paths and indexes are somewhat different in Neo4j compared to our other SQL. You saw how the cipher query language works on slides 35 and 36. This is a little description. Here, you see commands again using the cipher query language for Neo4j. Here, we have the various reasons some people use Neo4j as their NoSQL system of choice. Hopefully, with this video, in addition to the supplemental videos, you now have a firmer grasp on NoSQL systems.